Hi students, in this video we're going to cover the vertex formulas for quadratic functions. Our objectives are to use the vertex form of a quadratic equation to graph its parabola and to use the general form of a quadratic function to graph its parabola. All right, so a quadratic function is a second degree polynomial that has the form, you can see it f of x equals that thing, or we have the general form of ax squared plus bx plus c. The general form is just the expanded form of the vertex form. So if we have 2 times x minus 4 squared minus 5, the expanded form or the general form is 2x squared minus 16x plus 27. If a is greater than 0, the parabola is going to open up as we have in the red graph. So we'll just make a note here, a is greater than 0. And for the blue graph, this is going to be a parabola that opens downward and a is less than 0. The vertex is either the minimum or the maximum. We'll learn more about that. So, we actually have it here. So the vertex of a parabola is the absolute minimum if the parabola opens upwards. So here, this value that I'm writing here, that is what, 0, -4. So 0, -4 for this red graph is the absolute minimum. It's the lowest value on the graph. And that would make the range. So we'll say, for the red graph, we'll say the range is from -4 to infinity inclusive. And then for the blue graph, the vertex represents the absolute maximum, which is 0, 4. And for our blue graph, the range is from the highest value of 4. I'm sorry, that doesn't make any sense. It's from -infinity to 4. So the range is just from the vertex to infinity or -infinity for a parabola. And again, it's going to open up if a is positive. It's going to open down if a is negative. The axis of symmetry is the line that goes through the horizontal, the vertical line that goes through the vertex of a parabola. And the axis of symmetry has a property that values that are the same distance away from the axis of symmetry have the same output or the same y value. So our axis of symmetry here is x equals 3. And you can see that like both 4 and 2 are a distance of 1 away from the axis of symmetry. Well, a horizontal distance of 1, and they produce the same output. 5 and 1 are a horizontal distance of 2 away. They produce the same y value of 0. And 6 and 0 are a horizontal distance of 3 away, and they produce the same y value of 5. That's how the axis of symmetry works. If you have a point to the right, you have a corresponding point to the left that's the same distance away from the x-axis, from the axis of symmetry, and they get you get the same y values. The vertex form of a parabola is when we have this form a times x minus h squared plus k. The vertex of the graph is the point hk, and the axis of symmetry is x equals h. Notice we say hk and not -hk, so whatever number is here, do the opposite. The easiest way to graph a parabola is to start with, there are 2 ways. You can either start with the 5 key points of -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. Or I would use the vertex and then pick pairs of corresponding points around the axis of symmetry. In my opinion, this is the better way to do it. We'll see this on the next couple of slides. So for this example, we need to state the vertex and draw the axis of symmetry. We're also going to draw the quadratic function altogether. So the vertex is the opposite of whatever value is here. So since that's a +2, our x coordinate is going to be -2. And the y-coordinate is the value that's on the outside, so -3. Now, if you remember from our when we did transformations in Unit 1, we know that all this does is shift the parabola x squared to the left 2 and down 3. So we're going to have -2, -3 as our vertex. Cool. So that is our vertex. Now, in my opinion, it's easier to make a table. So since you have to graph this, we're going to make our table. And let's see, we're going to put 5 values in 1, 2, 3, and 4, and 5. And in the center, I would just put the vertex. So the vertex is -2, -3. And then if you pick a point 1 away, so let's say, so we're going to go from -4, -3, -2, -1, and 0. So these values are going to match up, the -1 and the -3, and the -4 and the 0 are going to match up. So if you substitute -3 into this, you're going to get -3 plus 2 is -1, squared is 1, and 1 minus 3 is -2. So that's going to be the same point for -1. So we get -3, -2, and -1, -2. And then with -4, so we can say f of -4 is -4 plus 2 squared minus 3, which is what? 4 minus 3, which equals 1. So -4 is going to produce a y value of 1. And because of symmetry, 0 is also going to produce a value of 1. So we have the point -4, 1, and 0, 1. And we can graph our parabola as so, like so. So we wanted to draw our axis of symmetry. The axis of symmetry is x equals -3. That is the axis of, I'm going to abbreviate symmetry. So x equals -3 is this line right here. That's our axis of symmetry. I didn't do a good job of drawing my parabola. No judgment. Example 2, we have, it's the same thing. We're going to state the vertex, draw the axis of symmetry, draw the parabola. So in this case, our vertex is the point 1, 9, because the opposite of -1 is +1, and the y-coordinate is just the value on the outside. So we have a 1, 9. So over 1 up, So over 1 up 9 is going to give us this point here. So now that means our axis of symmetry also is x equals 1. We'll draw that in, we'll say green. So our axis of symmetry is this dotted green line that I'm drawing right now. And we get that right here. So next we need to graph our, this parabola. So let's see. In the center, again, I would put the vertex. That is the point 1, 9. And so then again, I would pick the 4 points closest to that, 2 on each side. So I would go up to 2, go up to 3, go down to 0, go down to -1. And let's see. So 0 and 2 are going to match up, and -1 and +3 are going to line up as well. So when x is 0, f of 0 is going to equal -2 times 0 minus 1 squared plus 9, which is 1 squared is -1 squared is 1 times the -2 is -2 plus 9 is 7. So when x is 0, we get 7, and that's going to mean the same thing happens when x is 2. So then we can check maybe f of 3, and f of 3 is -2 times 3 minus 1 squared plus 9, and 3 minus 1 is 2, 2 squared is 4, 4 times -2 is -8, -8 plus 9 is 1. So let's fill in our table. We said 0, we had 0, 7, and 2, 7. And then f of 3 was 1, which is going to make f of -1 also 1. So over 3, up 1, left 1, and up 1. So we get our parabola to be something like that. And it should be a skinnier parabola because we have this vertical stretch of 2, and it should open downwards because a is negative 2. So that's how we graph a parabola that is in vertex form. The next form we have is the general form of a quadratic function, which is ax squared plus bx plus c. The x coordinate for the vertex is negative b divided by 2a. And whatever that value is, to get the y value, you substitute that in and evaluate it. So we get, so this is your x coordinate, and that is your y coordinate. The axis of symmetry is x equals negative b divided by 2a. So we're going to do a couple of examples with that. So we need to graph 2x squared minus 8x plus 1. So first we need to find our x coordinate for the vertex. That's going to be x equals negative b divided by 2a. So that's going to give us negative 8 divided by 2 times 2, which is 8 divided by 4, which equals 2. So then to find the y coordinate, you take this value of 2 and substitute it in. So f of 2 is 2 times 2 squared minus 8 times 2 plus 1, which is going to be, let's see, 2 squared is 4 times 2 is 8. So we have 8 minus 16 plus 1, which is 9 minus 16, which is negative 7. So our vertex is 2, negative 7. So we're going to go over 2 and down 7, and that is going to be our vertex. So again, once you have the vertex, it's easiest to make a table of 5 values with the vertex in the center of that table. So we're going to put in our 2 and negative 7. So we have x and y. And then I would just choose points that are, in this case, 1 unit away. So we're going to go up to 3, go up to 4, go down to 1, go down to 0. So now we have our 5 values. And then remember, the 1 and 3 are going to be paired up, and the 0 and the 4 are going to be paired up. So we need to just find f of 1 maybe, and f of, we'll do f of 1 and f of 0. So f of 0 is going to equal just 1, but we'll do the entire calculation. So 2 times 0 squared minus 8 times 0 plus 1, that equals 1. So we get 1, and we're going to get a 1 here. And then for f of 1, we're going to get 2 times 1 squared minus 8 times 1 plus 1 is 3 minus 8 is negative 5. And so we get negative 5 here. And we're also going to get negative 5 for 3. So now we can graph our parabola. We get 0, 1 is right up here. We had 4, 1 is right here. We had 1, negative 5 is right here. And we have 3, negative 5, which is right here. And I'm going to turn that around. And that's how the parabola looks. We need to add in the axis of symmetry. And so our axis of symmetry is going to be this dotted line that I'm drawing in. And that's it. So we graphed our vertex, put in the axis of symmetry, had our 5 key points, and we can graph our quadratic function. And the net is that, and so yeah, the last example for this section is going to be f of x is negative 1/2 x squared plus x minus 4. The x coordinate for the vertex is x equals negative 1 divided by 2 times negative 1/2, which is negative 1 divided by negative 1, which equals 1. The y coordinate for the vertex is f of 1 equals negative 1/2 times 1 squared plus 1 minus 4. And that's going to be, These are ugly numbers. So -1/2 plus 1 is a half minus 4. Let's just write that out. A half minus 4 is -3.5 or -7 halves. So we get 1 and -7 halves. So -3.5 is going to be like right here. That's our vertex. So then same thing is I would just choose values that are the same distance away from the vertex. So, I mean, from the axis, yeah, so from the vertex or the axis of symmetry. But we'll do something slightly different so that we get easier calculations. So when x is, so we have 1 -7 halves. So because we're going to be working with a square and a fraction that's a half, I would choose even numbers. So when x is 4, 4 is 3 to the right of 1. So I would go 3 to the left of 1 and get -2. And then if we choose like 6, then if I go 5 to the left, I would get -4. And we'll see what those points turn into. Hopefully they work out nicely. So again, the -2 and the 4 are going to pair up, and the -4 and the 6 are going to pair up. So let's do f of 4. So f of 4 is going to equal -1/2 times 4 squared plus 4 minus 4. And 4 squared is 16. 16 times -1/2 is -8. 4 minus 4 is 0. So we get -8. So when x is 4, we get -8. So that's going to be the same thing with -2. So we're also going to get a -8. So let's see, we get 4 -8 and 2 -8. So 4 -8 and -2 -8 is going to be right here. And then actually the 6's might be overkill. So when we get 6, let's see what we get anyway. So f of 6 is going to equal -1/2 times 6 squared plus 6 minus 4. 36, half of that is -18. -18 plus 6 is -12. Minus 4 is -16. So 6, -16, we'll just say is down here. And -4, -16 is going to be like over here. So when we draw a parabola, we still get the basic shape. But you get the point, is that we always have symmetry around this. Our axis of symmetry is going to go through x equals 1. All right. So that's going to conclude our video on vertex form and standard form. In the next section, we're going to talk about roots in a quadratic formula.